Friends, parents of students, welcome to 7.4. In our Unit 7, we have 5 lessons, so we're getting really close to the end. Here we go. 7.4, we're learning another property called the quotient of powers. We'll talk about that here in a bit, but before, let's recap with the properties we know. Property 1. Anything to the power of 0 gives us 1. When we have a negative exponent, we need to make sure we take it where it is and move it to the other side of our fraction. Here it starts in the top, it's going to end up in the bottom. When we move that fraction, the exponent changes from negative to positive. Property 3, this is the same exact thing. Oh, bummer. It looks like this lesson got hit by the format Scrooge. When we have a negative exponent, we just take the base and the exponent, move it to the opposite side. So here we're moving from the bottom into the top, and we make the exponent positive. When we multiply two of the same bases together, we can just add the exponents. When we have a power to a power, really what that means is if you see parentheses in an exponent, like we do here, we multiply the two powers together. If there's two things being multiplied, all of that is being taken to a power, taken to an exponent. We distribute that exponent to each of the bases. So here are A. Remember we could, oh yeah, sorry to warn you. There's going to be a bell right there. Have a good lunch. And then in 5 minutes there's going to be another bell. So let's see what we can get done in 5 minutes, shall we? And then this last one, same exact thing. When we see that parentheses and an exponent, we just go ahead and give that exponent to all of our bases. So we have a to the power of m over b to the power of m. Boom. Rock on. If we're confused or struggling or can't remember some of these properties, let's go back to some of the earlier videos and get a refresher on that. But assuming we're good to go, let's jump right into the beauty of quotients of powers. Look here. Here we have 3 to the 5th and 3 to the 2nd power as a fraction. That's really interesting. If I had written it like this, do you agree that if we were multiplying these together, that's where I would add the exponents together to get 3 to the 7th? That math would work. But this is a bit different because it's in a fraction. One's on top, one's on the bottom. Well, let's debunk it by doing this. When we see 3 to the 5th power, let's remember that we can write it out like this. When we see an exponent, we're saying, oh, I'm taking the number 3 and I'm multiplying it by 3 5 times, right? So 3 times 3 times 3 times 3 times 3. Well, 3 squared would then just be 3 times 3. There is a trick. When you see the same thing on the top and the bottom of a fraction, you can cancel it out. you can cross it out. So here, let's cross out the pairs of 3's. I see one pair, I see two pairs. What's left over here? What's left over? I see 3 3's left over. Well, so we could write that as 3 cubed, maybe, over 1. We put it over 1 because all of the stuff in the denominator canceled out. All we have left to do is calculate 3 to the third power is 27. Great. 27 over 1, but once again, when we simplify, we don't need to write that. Interesting. Let's look at another example. Very similar. Actually, let me zoom out to show you the similarities. Looking at example 1 and 2, look, the only difference, here we start with 3 to the 5th on the top, and this example 2, it's on the bottom. 3 squared is on the bottom, it moves to the top. Well, let's go ahead and write out the same process. 3 squared is 3 times 3. 3 to the 5th, 3 times 3 times 3 times 3 times 3. We can cross out the pairs. Now we're left with 3 3's in the denominator. So this is going to end up being 3 cubed with a 1 in our numerator. When we simplify this, we get 1 over 27 as our answer. So, hopefully you can kind of see how this gunk simplifies. There it is. There's our 5 minutes. Into 1 over 3 cubed. Now, of course, we did this process where we write it all out and then we cross out what's similar. There is a trick. There's a much quicker, much faster trick to doing this. It is the quotient of powers property. When we're dividing by the same base, okay, my pencil wanted to do funky things there. When we divide by the same base, we subtract the exponents. Interesting. I'll go ahead and go through these examples, at least the first 2 or 3. When we see example 3, we see 3 to the 8th over 3 squared. Let me ask you, first of all, looking at those two, which exponent is bigger, 8 or 2? It's a very simple question, but it's really important. Do we see how that 3 to the 8th is bigger? So when we do this process, we'll write it like this. We start with the biggest exponent, 3 to the 8th, and then we subtract the other exponent. So 3 to the 8 minus 2, that simplifies to 3 over 6, right? My question, now that we've found our reduced simplified answer, are we going to put it in the numerator, or should we put it in the denominator of an answer? You put this stuff wherever the bigger exponent was. So 3 to the 8th was in the top, so this answer, 3 to the 6th, goes to the top. Let me zoom back out to examples 1 and 2 to kind of show you this again. When we look at 3 to the 5th and 3 to the 2nd, which one of those two numbers is bigger, 5 or 2? Well, 5 is bigger than 2. So when we figured out our answer, 3 to the power of 3, we put it in the top, in the numerator. In example 2, well, now when we look at what we started with, our bigger exponent is in the denominator. So when we find out what's left over, we put it in the denominator. Oh, I didn't explain. This square where it has these 4 steps, that's just talking through these helpful hints and tricks, which I'm talking you through them. So you can read them on your own, but we're working through it with each example. Here, example 4, what do you think's happening? Well, which one's bigger? They're the same size. So let's just go ahead and start in. X 5 minus 5, well, what does that give me? 5 minus 5 is 0. Well, what's anything to the power of 0? It's just 1. So if I put x to the 0, this is a special case, I should say. If I put x to the 0 on the top, it still becomes 1 over 1, which equals 1. If I put x to the 0 on the bottom, that's still 1 over 1, which equals 1. The moral of the story: when the exponents match, they cancel out. I'm just writing this because it's a sentence that is important, spoken out. Because we have a x to the 5th, x to the 5th, they're the same thing. They'll end up just canceling out to be 1. Here in example 5, hey, go ahead and pause this and see what you think will happen. I'll go ahead and explain it after I drink some of my Dr. Pepper. Love Dr. Pepper. I'll go ahead and tell you that the correct answer is 3 over x to the 3rd. That's what we're looking for. I want to shrink you. I want to shrink you. Thank you. This is how we get it. We take it base by base. So when I look at this 3, is there anything that I can do to simplify that? No. I don't see any more base 3's anywhere in the problem. It just has an exponent of 1, so it's already positive, so I don't have to move it anywhere. So I just keep it in the numerator. Then, when I look at my x's, which one's bigger? X to the 8th is bigger. So I'm doing x to the 8th minus 5, giving me x to the 3rd. The answer goes where your bigger exponent started. So because it starts in the bottom, I'm going to put my leftovers in the bottom. Voila. Okay, go ahead, take a look at these 3 examples. If you can work through example 8 on your own, you should feel pretty good about the test, because that example 8 would be a great question, similar to what you would see as one of the harder test questions. Go ahead, pause. I'm going to start explaining these 3 examples right now. This one's nice. We have y to the 5th and y to the 10th. Which one's bigger? Y to the 10th. So y 10 minus 5 gives us y to the 5th. When we write our answer, will we put y to the 5th in the top or the bottom of a fraction? We will put it in the denominator because the bigger exponent started in the denominator. So this is the final answer. 1 over y to the 5th. Example 7. Take it base by base. So here, let's start with our x's. Our bigger x is 7. So 7 minus 5. When I simplify that, I get x squared. Will it go in the top or bottom of a fraction? You should put it in the bottom because 7 is bigger than 5. Now let's look at our next base. It's y to the 0, which is just going to become 1. That's our answer. Last example, and then you're on your own. Ooh. Here we go. The first thing we need to do is distribute this 4 to each of those bases in the parentheses. When I do that, I'm going to get this. Now that I've done that, we can take it base by base. So base by base, here's my x bases. When I simplify that, well, my bigger is 5. So 5 minus 4 gives me x to the power of 1. Because my 5 is bigger, x to the 1 goes in the top. Then we can look at the y's. Well, I have the bigger one is 9, so 9 minus 4 is going to be y to the 5th. The bigger exponent is also in the numerator, so I put y to the 5th in the numerator. That means I'm left with a denominator of 1, but when we write our final answer, we'll just write it as x times y to the 5th power. This is our answer. If you got that right, just on your own, on your first try, great job. Really good job. If we're still working through some of these concepts, well, my friends, that's why we have a couple of practice problems. We have 8 practice problems for you to look at and become pros with. If you have questions, of course, let me know. Ask a friend, ask a neighbor, ask me, and happy to work through these. Have a great day. Hopefully this helps. Goodbye.